Welcome back to Coffeesodes, everyone. Great to have you with us for episode 27.
Hi, everyone.
I'm Josh.
I'm Kelly.
And as always, you can find more details about the research we're diving into today down in the episode description, so take a look if you want to. All right, buckle up, because today we're launching a deep dive straight to the moon.
To the moon.
We're going to uncover some really cool facts about all the resources that are right there waiting for us, the potential for, conflict over those resources, and basically what it all means for the future of space exploration.
Big interesting.
I think so. So let's start with kind of a mind shift, I guess you could say.
Yeah.
We always used to think about the moon as this desolate wasteland, right?
Yeah.
Buzz Aldrin even famously called it magnificent desolation.
Yeah, just this big gray rock hanging in the sky.
Yeah, exactly.
Sure.
But here's where things get interesting. With all these new missions and new fancy mapping techniques, we're realizing that the moon's not so barren after all.
Yep.
Turns out it's got a surprisingly diverse and concentrated array of resources that are just kind of waiting to be tapped.
Mm-hmm.
So what does that mean? Well, it's sparked a modern-day lunar gold rush. Countries like China, India, Japan, Russia, and the U.S. are all racing to land on the moon in the next few years.
And it's not just governments anymore either, right? Private companies are jumping into the fray too. Names like PT Scientists, Moon Express, Astrobotic.
Wow.
They're all vying for a piece of the lunar pie.
So it's not your grandpa's space race anymore.
No, not at all. And the landing sites themselves are changing too. We're moving away from those, iconic Apollo sites near the lunar equator.
Right.
And setting our sights on new areas, particularly the South Polar region.
Yeah, I've heard about that.
Which seems to be a real hotbed for these valuable resources.
So it makes you wonder, what exactly are these resources that everyone's so hyped about? It can't be just rocks, right?
You're right. You're absolutely right. We can actually break these resources down into three main types: unique lunar features, valuable materials, and, believe it or not, cultural sites.
Okay, lunar features. Now that's intriguing.
Well, let's start with the peaks of eternal light.
Okay.
These are special spots, mostly near the lunar poles, that get almost constant sunlight. And that's thanks to the moon's tilt.
Wait, so never-ending daytime on the moon? That sounds pretty amazing for solar power.
Exactly. Stable temperatures, constant solar energy, perfect for a moon base or powering all sorts of lunar operations.
That sounds pretty ideal.
It does, doesn't it? But there is a catch.
Uh-oh.
These areas are super limited, only a few square kilometers each.
So even on the moon, prime real estate is a hot commodity.
It seems so.
I can already see the conflicts brewing over who gets access to these peaks of eternal light.
Right. Imagine, someone builds this giant solar tower on one of these peaks. It'd cast a huge shadow, potentially blocking sunlight from other installations.
Oh, wow.
Not exactly a recipe for friendly neighbors.
Definitely not. And what about these cold traps I keep hearing about? Are they really as frigid as they sound?
Oh, you bet. We're talking temperatures plummeting below minus 180 degrees Celsius. But the reason they're so valuable is that they're thought to hold water ice.
Okay.
And I'm not talking about a little frost here. Think ancient craters that have been in near total darkness for billions of years, basically acting like giant freezers, preserving water ice and other volatile materials from the early solar system.
Wait, water on the moon? That's huge. We're talking potential drinking water for lunar settlements, fuel for spacecraft, even scientific gold mines for, understanding the early solar system.
Like a time capsule.
Yeah, it's amazing.
Yeah. But here's where the complexity comes in.
Okay.
Some of these cold traps are pretty big, around 50 kilometers across, but the ones with the most valuable resources, the really cold ones, are much smaller, maybe only a kilometer wide.
So even within these cold traps, there's prime real estate, sparking even more competition.
Exactly, and we're not done yet.
Oh, there's more.
There's another fascinating lunar feature that has scientists, especially astronomers, really excited.
Okay, I'm all ears.
We're talking about smooth terrain on the far side of the moon.
The far side. The one we never see from Earth.
That's the one. Because it's always facing away from Earth, it's shielded from all our radio noise, making it the ideal spot to set up a radio telescope for deep space observation.
Oh, that's amazing.
It is, but the problem is there are only a handful of areas that are actually large and smooth enough.
I'm sensing a theme here. Everything valuable on the moon comes in limited supply.
You're catching on quick. And we've only just scratched the surface.
Yeah.
There's a whole other world of resources hiding on the moon, like those valuable materials we mentioned. Ready to dig a little deeper?
Lead the way, I'm all ears.
All right, then. Let's talk about those materials. So we were talking about these valuable materials that are found on the moon.
Right.
Let's start with something familiar, like iron. Pretty basic stuff, but incredibly useful for construction, especially if we're talking about, like, building structures in space.
Oh, that's right. Yeah, using materials already in space to build in space. Talk about cutting down on shipping costs.
Right.
But wait, how do we even know where to find iron on the moon?
That's where it gets clever.
Okay.
Scientists use magnetic readings to locate these iron deposits. But translating those readings into actual iron mass, well, that's still a bit of a puzzle.
So it's like a treasure map where we know the general area, but not the exact X marks the spot.
Exactly.
Gotcha.
Now, besides iron, there's also thorium and uranium, both potentially useful as fuel sources.
Okay.
However, the concentrations on the moon are actually pretty low compared to what we find here on Earth.
Oh, okay.
Plus, you guessed it, the areas with higher concentrations are, you guessed it, pretty small and limited.
Limited resources again. It's starting to feel like a cosmic game of musical chairs.
A very apt analogy.
Right.
And then there are the rare earth elements, or REEs for short.
REs, those ring a bell. Aren't they essential for tons of technology here on Earth?
Absolutely. Everything from your smartphone to electric car batteries relies on REs.
Wow. Yeah, that's right.
The problem is, while they're not technically rare on Earth, extracting them is a messy and often environmentally damaging process.
So the moon could offer a cleaner source for these essential elements.
Potentially. But there's that word again, potentially.
Right.
We really need more detailed mapping to know for sure if the concentrations are high enough to make lunar mining worthwhile.
I see. Yeah, that makes sense. All right. Iron, thorium, uranium, REEs. Anything else I should add to my lunar shopping list?
Well, there's one more you've probably heard about.
All right.
Helium-3 is definitely something to keep an eye on.
Okay.
The moon has been soaking it up from the solar wind for billions of years.
Wow.
But I bet you're going to tell me it's concentrated in small, hard-to-reach areas.
Well, yeah, I was kind of thinking that, given the pattern so far.
You're on a roll today.
Huh?
The higher concentrations of helium-3 are found in a handful of small regions, less than 50 kilometers across.
Yes.
And here's where it gets even more interesting. Remember those smooth areas on the far side of the moon? Perfect for radio telescopes.
Yeah.
Well, one of the most promising sites, Mare Moscoviensis, also happens to have high concentrations of helium-3.
Oh, so we've got scientists who want to build a radio telescope and folks who might want to mine helium-3.
Oh.
All vying for the same piece of lunar real estate.
That's right.
Sounds like a potential recipe for conflict.
You're catching on quickly. It highlights the complex web of competing interests we're going to have to navigate as we venture further into space.
Yeah, for sure.
It's not just about what's on the moon, but also who wants it and what they want to do with it.
Right. Okay, so we've got a handle on these lunar features and materials, but you mentioned a third type of resource.
Yeah.
Cultural sites. What are those all about?
It's an interesting ethical dimension, actually. Think about those iconic Apollo landing sites.
Yeah, they're like historical landmarks. We need to preserve them.
Exactly. There's a growing movement to protect these sites from damage or exploitation. Organizations like For All Moonkind are leading the charge, and even NASA has issued recommendations for their preservation.
It makes sense. These sites are part of human history. It would be a shame to lose them in a rush to mine the moon.
Absolutely.
Well, I imagine things could get a little tricky when multiple players want access to the same limited resources. Who gets to decide who gets what?
That is the million-dollar question.
Yeah.
And it's where the legal and political landscape gets really complicated.
Okay, hit me with it. What are the rules of the game in space?
Well, the primary framework we have is the 1967 Outer Space Treaty. You can think of it as the Constitution for space exploration.
So no planting a flag and claiming the entire moon for yourself.
Exactly. But here's where things get a little murky.
Uh-oh.
The treaty also states that countries need to show due regard for each other's activities in space and avoid causing potentially harmful interference.
Due regard and harmful interference. Those sound like pretty broad terms.
Yeah.
Open to interpretation.
They are.
I can already see how that could lead to disagreements.
You're absolutely right. And those disagreements are starting to emerge.
Okay.
There's a lot of debate about what exactly these terms mean, especially when it comes to activities around these valuable resource sites.
Right, okay.
Yeah.
Can you give me an example of what kind of interference we're talking about?
Sure. Imagine you have a sensitive scientific instrument, like a telescope, set up in a prime location.
Yeah.
Now, another mission comes along and wants to land nearby.
Okay.
Even if they're careful, the landing itself could kick up dust and debris, potentially damaging the instrument.
So even unintentional actions could have consequences.
Right.
It's like trying to tiptoe through a lunar minefield.
That's a good way to put it.
Yeah.
And then there are things like blast ellipses to consider.
Blast ellipses. Okay, you've officially piqued my curiosity. What are those?
Well, when a rocket lands or takes off, its engines create this massive blast of hot gas and dust.
But
This blast zone can extend quite a distance, causing potential damage to anything in its path.
oh, wow. So if you're setting up camp near a resource site, you better make sure you're well outside someone else's blast ellipse.
Exactly. And these ellipses can be huge depending on the size of the spacecraft and the power of its engines.
I see.
It all adds another layer of complexity to figuring out who can do what and where on the moon.
It's all starting to sound a little chaotic. It seems like we need some clear rules and regulations to prevent the moon from turning into a cosmic free-for-all.
You're spot on. And that's exactly what we're going to explore in our next segment.
So we've uncovered this incredible wealth of resources on the moon, from helium-3 to potential water ice and even these historically significant cultural sites. But with all these competing interests vying for limited resources, it kind of feels like we're on the brink of a cosmic land grab. How do we even begin to govern this new lunar frontier?
That's the million-dollar question, isn't it? And honestly, we're writing the rule book as we go.
Yeah.
There's no precedent for this kind of large-scale resource management in space.
So where do we even start? It feels like uncharted territory. Is there anything we can learn from how we manage shared resources here on Earth? After all, we've been dealing with these kinds of challenges for centuries.
You're absolutely right. And thankfully, there's a whole field of study dedicated to just that, managing what are called common pool resources. These are resources that nobody has exclusive rights to.
Like international waters or the atmosphere.
Exactly. And researchers have been studying for decades how to avoid the tragedy of the commons, where everyone acts in their own self-interest, ultimately depleting the resource for everyone.
Yeah, I mean, repeating that scenario on the moon would be a disaster. So what are some of the key lessons from this research that could help us navigate lunar governance?
Well, one crucial insight is the need to balance principle and practice.
Okay, meaning?
It means we need a solid foundation of principles for space resource management, like those outlined in the Outer Space Treaty. But we can't get bogged down in endless negotiations trying to create the perfect international agreement before anyone can even lift a finger. We need practical, on-the-ground solutions that can adapt and evolve as we learn more.
So a little trial and error, guided by a set of core principles to keep things from going completely haywire. Okay.
Another critical element is focusing on shared interests.
Yeah.
Getting every nation and private company to agree on a single best outcome is almost impossible, especially with so many different motivations at play.
Right. But what if, instead of trying to define the best outcome, we focused on what everyone wants to avoid? Things like resource depletion, unfair appropriation, or damage to cultural sites. I mean, finding that common ground could make cooperation a lot easier.
Makes sense. Avoid the bad stuff, even if we can't agree on the perfect way to do the good stuff.
Exactly, yeah. What else stands out from this research?
One point I find particularly relevant is the need to clearly define the problem we're trying to solve. What exactly are we sharing here? Is it the physical area itself, the resources we extract, the benefits we derive? And how do we decide the optimal level of exploitation? How do we distribute those benefits fairly? These are tough questions, but we can't shy away from them.
It's like trying to set the rules for a new board game. If the rules are vague or unclear, nobody's going to have any fun and everyone will end up arguing.
That's a great analogy.
Right.
One more point I'd like to emphasize is the importance of lengthening the time horizon.
Thinking long term.
Exactly.
Okay.
It's easy to get caught up in the excitement of immediate gains, but cooperation becomes much easier when we consider the long-term consequences of our actions.
But how do we translate this long-term thinking into concrete governance structures? What would that actually look like on the moon?
One promising approach is the idea of nested platforms.
Okay.
Imagine local site management with its own rules and regulations tailored to the unique resources and challenges of that particular site.
And then those local sites, are nested within regional structures, and finally, everything falls under a lunar-wide governance system.
You got it. It's like a set of Russian nesting dolls, each level of governance fitting within the next. This allows for flexibility and adaptability at the local level while ensuring consistency and fairness across the entire moon.
So nested platforms, long-term thinking, focused on shared interests. I'm starting to see a path forward here.
Yeah.
But even with the best intentions, what's stopping someone from going rogue and ignoring the rules? I mean,
Yeah.
enforcement in space seems incredibly
Oh,
difficult.
it's a valid concern. Enforcement is definitely tricky, but one idea that's been proposed is a concept of withholdable carrots.
Withholdable carrots. Now that sounds intriguing. Tell me more.
It's about positive reinforcement rather than punishment.
Okay.
We could create shared infrastructure, things like landing pads, communication networks, or waste management systems that benefit everyone.
But access to those benefits could be withheld from actors who refuse to play by the rules. It's like a way to encourage good behavior without resorting to force.
It's like a cosmic rewards program.
Yeah.
Follow the rules and you get access to the best lunar perks, break the rules, and you're stuck with the basic package.
Exactly.
And it highlights a crucial point. We're all in this together.
Yeah.
The moon isn't some unclaimed territory ripe for exploitation. It's a shared environment that demands cooperation and responsible management if we want to create a sustainable future in space.
Well said.
As we've learned, the moon is a lot more than just a barren rock in the sky. It's a treasure trove of resources, a scientific wonderland, and a reflection of our own history. What we choose to do with it next is entirely up to us. Thanks for joining us on this lunar journey. We hope you've learned something new and that it sparked your curiosity about the future of space exploration. Until next time, keep looking up.